So I've been a developer for the past 10 years. I've been working on websites and apps and all that kind of stuff. And one thing that I haven't really been able to ignore over the last couple of years has been the rise of AI. I'm a person who learns by doing, and whenever I'm picking up a new technology, I need to start by building the simplest version of anything that I possibly can, and I could not find a video that taught me exactly that. And that is why I have made this video. I have written and shot this course in a way so that we can get from A to B as quickly as we can. But the purpose of this video is for you to come away and have your very own AI app built just by watching this video. So I personally would recommend just grabbing a tea or coffee and just sitting back and watching the entire thing start to finish. And then the second time around, you can follow along with your own code and produce the app yourself. And so I feel like I've probably rambled on enough now. I'll let you get into it, and hopefully I will see you at the end. So before we get started today, let me show you exactly what it is we're going to be building. So on the front end, we've got this input field and we've got this button that says generate my plot. And under the hood, we've actually got a fine-tuned model, which has been trained on a Wikipedia dataset of movie descriptions. So when we enter the beginning of our movie description, it's going to then our model is going to generate the rest of it. So let's give it a try. I'm going to go a movie set in the 1920s, go starring, and see what it comes up with. And it should generate something which sounds like a movie plot. A movie set in the 1920s starring Captain America and the Golden Age movie about a European aristocrat named Tom is set in Europe. Okay, interesting. So how about a young man and his son set out to, let's see what we get. Find the girl that they had been expecting. Afterwards, the couple find themselves pursued by two men, the one of whom they had married. So not bad results, as you can probably see, but this has actually only been trained for about 15 minutes on 1,000 items of data. So you can imagine that if we added more data to this, or maybe trained it for a longer period, we'd probably get an even better model. But this is what we're going to be building in today's tutorial, which should be a great starting point for you to be able to go and build your own models from in the future. Okay, so we're just about ready to start, but the first thing we need to do is set up our virtual environment, which is what we're going to be using to install all of our Python requirements into. Now, as you can see, I've opened up Visual Studio Code and I've just created a directory called My First LLM. This is going to be where we're going to be storing all of our files in, and we're also going to be storing our virtual environment files in here too. So to get started, let's open up a terminal inside of Visual Studio Code. You can do that by hitting Control and tilde, or you can click on Terminal, New Terminal up here. I'm just going to clear it, and then I'm going to type in python3 mvenv.venv. And what that's going to do is create us a new virtual environment inside of this directory that we are working in, which is 11 my first LLM. Next, we are going to want to activate it, and to do that we can just go source.venv/bin/activate, and now we can see that .venv is in parentheses, which means that we have activated our environment and we're safe to start installing our dependencies inside of it. And so with that in mind, let's install all the dependencies that this project is going to require. So those are going to be Torch, which is PyTorch, Transformers, which is the HuggingFace Transformers library, datasets, HuggingFace datasets, then pandas, and Transformers Torch. Now, this last one, I put it in quotes here. The reason for that is because I'm using ZSH. If you are not using ZSH, you might need to get rid of these quotes. I would try both. So maybe try with quotes. If you get an error, then try without quotes and see how you get on. For the time being though, I'm just going to let this run and install all of these packages into my virtual environment. And that looks like we are all ready to go. So let's get rid of this terminal and then create ourselves a new Jupyter notebook. This is going to be called my first LLM.ipynb. Now, you might be wondering what an ipynb file is. An ipynb is the suffix for a Jupyter notebook. And if you haven't used a Jupyter notebook before, all you need to know is it's an environment in which you can run Python code as code blocks. Before we continue, we need to know that Visual Studio Code is also using the same virtual environment that we just set up. And you can do that by hitting this little button in the top right hand corner. This might say select kernel for you. For me, Visual Studio Code has already figured out the virtual environment that I want to use, but I'm just going to click it anyway. And then I'm just going to select the virtual environment that I've just set up. And you can identify that this is the correct instance because it says .venv/bin/python. You might have a couple of other options which maybe point to different areas on your drive. The one that you want to use starts with .venv. So right at the very top, we are going to declare a couple of variables. We're going to declare our model name, and that's going to be DistillGPT-2. We'll talk through that in a little bit. And we are also going to declare our device, which is going to be CPU for the time being. We'll probably change that later on, but for the time being, we are just going to set our device as CPU. And then we are safe to actually hit play on this code block. You might be presented with this little message, which basically just says that Visual Studio Code requires some additional packages. If you just hit install, it will go ahead and install all the required packages that you need for Visual Studio Code to play nice with Jupyter notebooks. And now we can see that those have installed, and there's a little tick there, which means that our Jupyter notebooks are behaving as expected, and this code block has run without any errors. So we're all good to go. So to add some context as to what DistillGPT-2 is, basically, we are going to be fine-tuning a model in this tutorial, which means that we're not going to be building a neural network from scratch. It means that we're going to be taking an existing one and fine-tuning it to do a task that we decide. Specifically, we're going to train it on a dataset of IMDb movie synopses, which ultimately means that it's going to get very, very good at generating a movie synopsis from scratch. However, to get there, the concept of English needs to be understood by the language model. Now, that would take us a very, very long time to be able to train, and a lot of GPU resources just to get that off the ground. The benefit of fine-tuning is we can take an existing model that maybe knows English very well, like DistillGPT-2, and then we can fine-tune it to do the thing that we want it to do, reaping the benefit of all of that English knowledge that the model already has. Okay, so with that out of the way, let's create our tokenizer and our model. So I'm going to create a new code block. I'm going to import from Transformers the auto tokenizer class and the auto model for causal LM class. Now we just need to initialize our tokenizer. So we'll declare a new variable as tokenizer, and we're going to use that auto tokenizer class that we just imported. We're going to call the from pre-trained function, and we're going to pass it that model name that we declared at the very top of our file just here. Next, we might run into errors if we don't set this line, so we're just going to go ahead and set our pad token on our tokenizer to our end of sentence token. So we're just going to go tokenizer.pad token equals tokenizer.eos token. You don't need to worry too much about this at the moment. The main thing is to just keep in mind that more often than not it needs to be done, otherwise you might run into errors. So next we are going to go ahead and run and create our model. So we're going to initialize our model as into the model variable, and we'll call our auto model for causal LM class that we imported at the beginning. Once again, from pre-trained, and we're going to pass in our model name once again. And to round this off, let's just log our model to our output and hit play. And if everything's gone well, we should hopefully be able to see, yep, a GPT-2 head model, which has been imported. So our tokenizer and our model are all initialized exactly as we expected. So we're good to move on. Now I said that we're going to fine tune this model on our own dataset that we provide. We aren't actually going to create that dataset. We're actually going to fetch it from a website which hosts many datasets, or rather a community which hosts many datasets called Kaggle. So I'm going to Alt Tab over to my Chrome instance, and we can see that Kaggle is up already. It's just available at kaggle.com, which you can get to here. I'm already logged in. I'm just going to go ahead and search in this top bar for movie plots, and then just click here. And then I can see that right at the very top is this dataset, that I want to use, which is called Wikipedia movie plots. Now, if I click through to that, we can see, if I click on view more, oh no, sorry, it's a little bit further down. I can actually see examples of each of the data items inside of this data set. So we've got a column which is called the release year, we've got the title, we've got the director, but we want to train this model to get really, really good at replicating the actual plots of these stories. So what we're actually looking for is a synopsis, and as we can see, there is a column called plot, and this looks exactly like what we're looking for. The film, just over a minute long, is composed of 2 shots lasting just 61 seconds. A lovely little synopsis. Like, the idea is that our model is going to get really, really good at replicating these kind of plots. Now, to carry on, we just have to hit download in the top right hand corner, and it should download us our CSV to our drive. And then what I'm going to do next is extract that and import it into that directory that we are working in. Okay, so I've downloaded this movie plots dataset. So I'm going to create a new code block here. I'm going to import pandas as PD. Next, I'm going to create a data frame. And the way I'm going to do that is declare a new variable called df. And I'm going to go pd.readCSV. And I'm going to point it to the relative path of our movie plot CSV that we just downloaded. So I'm just going to go /movie plot CSV, and then I'm going to log that to the output so that we can see what it's loaded in. So if I hit play and just wait just a second while it loads those data in, we now have a much more easier to read data set, which we can see if we scroll along. We can see that we've got the wiki page, we've got the genre, we've got the plot. It's a lot easier to read than that sort of wall of text that we had earlier on. Okay, so we have imported our movie plot CSV, and if we scroll down, we can see that there are around 35,000 rows in this data set. Now that's pretty big. It's a big data set. It's going to take a while for us to process all that stuff. We can sort of get a subset of this data, a smaller set, and we can train it in a short amount of time. And if we feel like it's going in the right direction, i.e. the results that we're getting seem promising or point in a direction that we're going to get a good model out of it, we can then expose the model to the entire data set. What we're going to do in this tutorial is we are just going to siphon off the first 1,000 rows. So we're just going to take the first 1,000 plots from this data set. We are going to fine tune our model using those 1,000, and we're going to see what kind of results we get. So to do that, first, we're going to create ourselves a new code block, and all we need to do is just reassign our data set, our data frame, sorry, and we are just going to take the first 1,000 items from that data set. So if I hit play on this, we can now see that our data frame only has 1,000 rows in it now, which means that we've only got 1,000 plots, which is great. Okay, so right now, all of our data is inside of a pandas data frame. In order for us to use the Transformers library to train our model, we actually need to create a dataset from this, which is using the HuggingFace datasets library. So in order to do that, we are just going to go from datasets, import dataset, and then we are going to create ourselves a new dataset, and we'll just assign it a variable called dataset, and we'll go dataset from pandas, and we are going to pass it that data frame that we created earlier. And then we can just log to our output that dataset. And as you can see, we now have a dataset which has the features, release year, title, origin, ethnicity, director, cast, everything like that. These are all the column names that we could see inside of our data frame just above. Next, what we're going to do is we're going to tokenize our dataset. That ultimately means what we're going to do is going to provide all of our data as an input, and then the output, we're going to get a bunch of numbers, and those numbers are what's known as tokens. Those tokens are a numeric representation of the inputs that we provided. So to do that, I'm going to reassign our dataset, and this time I'm going to run a function called map on it, and I'm going to pass in a couple of arguments here. So I'm going to pass in a function called map dataset, which I'll declare in a minute. Next, I'm going to pass in batched as true. I'm going to pass in our batch size as 8, and then I'm going to pass pass in a property called remove columns, and we are going to want to remove all the columns that are in our original data set. So we're just going to grab all the columns from our data frame up here. So we'll cast them to a list and we'll go df.columns. Next, we are going to need to declare that map dataset function that we just declared. So we're going to go def map dataset, and we're going to take a batch as an argument. And then for the time being, let's just go return batch, and we can carry on from there. So I'm going to hit play and everything. And at the moment, we currently have a dataset with no features, but we will fix that in a second. So right at the beginning of this tutorial, you might remember, we declared a tokenizer just here. Now, this is where we're going to actually start using it. So I'm going to scroll back down to this block here, and I am going to get rid of this line which says return batch and replace it with return tokenizer. I'm going to pass in a few more arguments. So the first thing I want to do is I want to pass in our batch, but more importantly, this batch is going to come with all of this additional metadata like the release year and the title and the director and all that stuff that we don't want. So the only thing that we care about is the plot. So we're just going to pass in batch plot as the data that we want to tokenize. Next, we're going to pass in a property called truncation, and we're going to set that to true. We are going to set the max length to 128 tokens, and we are going to specify return overflowing tokens to true. So now I should be safe to hit the play button, and we can now see that we've got a dataset full of these three features: input IDs, attention mask, and overflow to sample mapping. And we've got 2,736 rows in there. So that's looking really promising. The only thing that we really need to do now is we actually don't need this overflow to sample mapping for at least for this example. So what I'm going to do is I'm going to do one last thing where we go dataset equals dataset dot remove columns, and we are going to just get rid of that overflow to sample mapping, and I believe I need to put that inside of an array as well. So we'll do that, and then we'll hit play, and now we can see that our dataset consists of two features: input IDs and attention masks, which is all we need. So the final step that we need to do to our dataset is to split it into two separate datasets. So we want to split it into a train dataset and a test dataset. So to do that, it's actually super simple. We can just go dataset, we're just going to reassign it again, and we're going to go dataset.train test split. And we are going to specify our test size to be 0.2, which ultimately means 20% of our data, or this data set, is going to be used as test data. The other 80% is going to be used as training data. And if I hit play on this block here, we can now see that our data set has turned into a dataset dictionary, and we have a train dataset and a test dataset with the correct ratio here. So this is 80% and this is 20% of the data. Next, we're going to create a data collator. And to do that, I'm just going to create a new block of code. And I'm going to once again import from our Transformers library. This time I'm going to import the data collator for language modeling class. And I'm going to declare our data collator as data collator equals data collator for language modeling. We're going to pass in our tokenizer here. I'm actually going to just break it down onto another line so it's a bit easier to read. So we're going to pass in our tokenizer, and then we also just want to pass in a variable called a property called MLM, and set that to false. And then we're just going to log that data collator to our output and hit play. And if everything's gone well, we can see that our data collator has come through and our tokenizer has been assigned to it, which is great. Next, we'll set up our training arguments and our trainer. So I'm going to create a new block of code. I'm going to once again import from Transformers. This time I'm going to import training arguments, and I'm going to import trainer. I'm going to declare a new variable called training args, and we're going to initialize a new instance of the training arguments class. We're going to specify an output directory, which is going to be the output directory for our model. So we'll go /output/model. We are going to set our evaluation strategy to epoch. We're going to set our learning rate to 2 to the power of -5, And then we are going to set our weight decay to 0.01. The number of epochs we want to run at the moment is just going to be 10. And that should about do it, actually. So next we want to initialize our trainer. So I'm going to go trainer equals trainer. Once again, I'm going to pass in our model that we've been working on. I'm also going to pass in our train dataset, which is going to be our dataset that we created just up here. So dataset. But we want to just pass in the train dataset, not the entire dataset dictionary. So we're going to go dataset, and we're just going to grab the train dataset within that dictionary. We also want to pass in our test dataset, sorry, our evaluation dataset. So we're going to go eval dataset equals dataset test. And then we are going to pass in our training arguments as the parameter args. And then finally, we are ready to run trainer.train, which is going to do all of the heavy lifting for us and hopefully fine tune this model on the dataset we provided. So with that, we're going to hit play. And we have hit an error. Expected sequence of length 128 at dim1. This means that we haven't passed in our data collator. So I need to just add one more argument here, which is going to be data collator equals data collator. And then we can hit play, and this is now training exactly as we'd expected. So it looks like this is going to take around 15 minutes for me to do 10 epochs on this model. So I will run these, I'll run these epochs and come back and see how we get on. So we've successfully trained our model. The next thing that we need to do is just test it out and see how good this model is at generating plots from scratch for us. So let's create a new block of code. This one I'm planning to pull out and put into a separate file later on. So I'm actually going to redeclare a few things just so it can be run in isolation. So we're going to go from Transformers, import Outtro tokenizer, auto model for causal LM, so exactly the same as what we did before. We are going to redeclare our tokenizer, and we're going to go auto tokenizer from pre-trained. We're going to pass in distilled GPT-2, which is the tokenizer that we have been using up until now. Then I'm going to provide I found that Transformers tends to error if you don't provide it with a padding token. So what we're going to do is or sometimes warnings. So what we're going to do is we're going to set our pad token to tokenizer.pad token equals EOS token, which basically just says that we're going to use our end of sentence token for our padding token in this instance. Next, we are going to want to create a new instance of our model. So we're going to go model, auto model for causal LM from pre-trained. But this time, instead of using distilled GPT-2 as a reference to our model, we're actually going to point it to the output that we've just created from our training. So if you come over to the left side of the screen, you can see that we've now created, or since we've trained, we now have a directory called output and then a subdirectory called model. And inside of that, a bunch of these checkpoints directories. Now we want to take for now our latest version, so our latest checkpoint, and so we can assert that by just looking at the largest number at the end of this checkpoint. So right now it looks like checkpoint 2500 is our latest model, so we're going to take that one and we're going to load it. So we'll go from pre-trained and we'll point it to a relative directory, which is going to be /output model checkpoint 2500. And then, just for now, let's just log that model to the console and just make sure it's coming through as we expect. So I'm going to hit play. And yeah, that's exactly what we were hoping for. So this is our GPT-2 head model, exactly the same as our distilled GPT-2 model, but we've just added an additional layer during our fine tuning, which hopefully is going to make this a lot better at creating plots from scratch. So now we're going to get onto the more exciting stuff. We are going to actually provide our model with some inputs, which is going to be our prompt, and we're going to just watch as our model generates the rest of that sentence or our plot for us. So let's go prompt equals. I want to do. Let's try and get it to create a film about a short film about a pilot who. And see what it comes up with that. Next, we need to turn this prompt into tokens that our model can understand. So to do that, we're going to go inputs equals tokenizer. We're going to pass in our prompt, and then we are going to specify that the type of tensors we want to return are in the PyTorch format. So that's return tensors equals PT. And then finally, we just want this to make sure that we have this on the CPU, not on the GPU right now. So let's just log those inputs to our output just to see what these look like. I'm hoping for a bunch of numbers. Yep, we've got an object which is our input IDs and an attention mask, and our input IDs are a bunch of numbers. So that's exactly what we want. So now what we can do is now that we've converted these, we've converted our prompt into tokens that our model can understand, we can actually get some outputs out of the model that we've just created. So we're going to go outputs equals model.generate, and we are going to pass it our prompt. But we're going to pass it our inputs. But we're going to pass it the input IDs on that object that we got. We are then going to pass in an argument called max new tokens, which is basically going to say to our model, don't generate any more than 100 tokens. We're going to then provide a couple of these additional parameters that I actually found on the HuggingFace documentation. So do sample is going to be true. We're going to provide a value of top K to 50, and we're going to provide top P as 0.95. So if you wanted to, you can experiment with these values here, and there are plenty of other parameters that you can experiment with that are detailed on the HuggingFace documentation. But for now, from my own tests, I've actually found these to work really, really well. So we're going to run with these for the time being. So now that we've generated our outputs, let's just go ahead and log these to the console. So in the same way that our inputs were a bunch of numbers, or tokens, we're hoping that we're going to get a bunch of tokens out of this too. And exactly as we'd expected, we've got a tensor which is filled with a bunch of numbers. So this is great. This is indicating to us that our model is working. It is generating these tokens for us, which is really exciting. But sadly, right now, we actually can't make head nor tail of exactly what this says. So we need to turn this into from tokens into a string, so convert them back into a string. And thankfully, our tokenizer offers the functionality to do that too. So we're just going to go output string. So we'll declare a new variable, and we'll go tokenizer.batch decode. And we're going to pop in the outputs that we just generated. And then finally, we're going to log that to our output. And we're going to hit play. And hopefully, we should have a plot about a short film about a pilot. A short film about a pilot who accidentally kills a star, and the scene in which the pilot is shot is reframed by the screenwriter John Haynes, Cannibal, and the subsequent reframing. Okay. Interesting. I'm going to hit play and try another one. Let's see what we get this time. A short film about a pilot who accidentally lands in the desert. He is able to film for the first time. When it becomes clear he cannot film for his wife, he decides to take it home and do it. When the aircraft is destroyed, he is able to film on film. When he sees the wreckage, he realizes that he is from a small village. So to me, this feels like a success. And whilst it's not generating the most perfect plots in the world, it's doing a pretty good job, and it's good enough for me. And so I think with that, I think we're good to carry on and onto our last step of this project, which is just going to be to wrap some UI around this, which is pretty exciting. Right, so you might be wondering, now that we've built our model, how are we going to build this front end that I showed at the very beginning of our video? So to do that, we're going to use a library called Streamlit. Streamlit is this really awesome library that I came across recently, which ultimately allows you to write UI using Python, and then when you're ready, you can actually deploy it to the cloud with like very, very little effort, which is really cool. It also plays really, really nicely with generative AI, so this is kind of a perfect match for us. So to get started, what we're going to do is we're going to create ourselves a new file inside of our directory. We're going to call it app.py. And then I'm just going to open a terminal instance. I've actually got one ready here, and we are actually in the directory that our project is located in, and we are just going to activate our virtual environment using that command that we used earlier, which is source venv bin activate. And as you can see, we've got our venv in parentheses, which means that we are inside of our virtual environment. Next, we want to install Streamlit, which is the library that I was just talking about. And now that's all installed and ready to go, we can actually just run streamlit hello, just to verify that it's working okay. And we get this kind of like basic sort of welcome to Streamlit starter page to verify that we have installed Streamlit exactly as expected. So we're ready to go. Right, so before we start, what we want to do is we actually want to wrap all of our logic inside of a class that we can initialize once and then reuse over and over again. So to start off with, first we're going to go to my first LLM, and we can just grab this entire code block from here, and we are now going to basically refactor it and put it inside of a class. So I'm going to hop back over to our app.python file. I'm going to paste it in. Everything is lit up as expected. If it hasn't, do pop down to this little button down here and make sure that your virtual environment is set to venv bin python, which is the virtual environment that we set up earlier. And next, what we're going to do is define our class that we're going to wrap all of this logic into. So first, I'm going to go class. I'm just going to call it app model. And then we are going to need two functions. So we are going to go init, and we are going to pass in self. And then we are going to create another function called generate plot. We're going to once again pass in ourselves, but we are also going to pass in a string for our prompt. We're going to use this function later when we want to generate our plots based off the input that our users give. So now that we've got our init function and our generate plot function, we can start copying and pasting some of this logic into our class. So our initializer, we actually just want to initialize our tokenizer and our model. So to do that, we can just cut and paste these three lines here and just paste them into our initialize function. So that's nice and clean. We want them to be attached to our class. So in order to do that, we are going to go self.tokenizer, 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 and self.model, just so that they are attached to our class and they stick around rather than reinitializing every single time we initialize our app model. Next, we've got our generate plot function. So now what we can do is, because we actually already have our logic that we use to generate our plot, we can just cut and paste it into this function here, which should be nice and easy for us to do. We do have to make a couple of changes to the tokenizer and model references, because we define them as attached to our app model class. So we're going to go self.tokenizer, self.model, and self.tokenizer once again. So and finally, we need to return our output string rather than just sort of have it hovering around at the end there. So what we've got is our app model class now, which has got an initializer, which is going to create our tokenizer and our model, and we have a function on that class which is going to generate a plot. However, at the moment, you might have noticed this already, we are still using the prompt that we were generating or that we were using earlier on inside of our code, inside of our Jupyter notebook. We actually want to use the prompt that is passed into the generate plot function. So to do that, we can just get rid of this prompt line which says a short film about a pilot who, because we don't want it to be hard coded anymore. We want it to be used whatever the prompt is that is passed into the function. Finally, we need to make sure that our app model doesn't get regenerated every single time our Streamlit app refreshes, which happens a lot. So to do that, we are going to import Streamlit as st, and we are going to mark our class as something called st.cacheResource. So this is a decorator, which is ultimately saying that this class cache it, make sure that it sticks around through each run of the re-renders that Streamlit goes through. That will mean that if we don't have this decorator, then the tokenizer and the model may get recreated with every single click or interaction that we make with our Streamlit app, which wouldn't be any good. So what we're going to do is just add this decorator here, and that should do everything that we need to. And finally, we are actually going to write the UI components now for our app so that a user can input their prompt and get an output out. And it's going to sort of look like a little bit of a chatbot. So to do that, we first need to initialize our model. So we're going to go model equals app model, and that is just going to create an instance of this class that we've just created here. And then what we want to do is we want to go prompt st.text area, and we can pass in one argument, which is going to be that little prompt at the top of the text box to tell the user what to enter in. So in our case, it's going to be enter the beginning of your plot. Next, we want to declare a variable called clicked, and I'll talk about this in a minute. But again, we are going to go st, but this time st.button, and the first argument that it takes is the button function takes is the name or the title of the button that we want to set. So we are going to go generate my plot, because we want our button to say generate my plot on it. So now if I hit save, and then if I head back over to my terminal instance, I'm going to run streamlit run app.py, and hopefully we should have, you can see that it's initializing our app model. We can see that we've got a text field and we've got a generate my plot button. So if I enter a plot here and hit generate my plot, you see a flash in the top right hand corner, but nothing actually happens. And the reason for that is we haven't actually defined any behavior for when we click the button. But the good news is adding that behavior is super straightforward. So we're going to go back over to our Visual Studio Code, and we are just going to go if clicked. So if clicked equals true, basically, we can actually just go ahead and generate our plot. So we'll cache it as into this variable called generated plot, and we will once again call our model, but this time we're going to call the generate plot function on it, and we are going to pass in the prompt that has been collected from this text area just above. So we'll go generated plot equals model.generate plot is prompt. And actually what we could do here is we can just print this plot to the console and just see what happens. So once again, I'm going to head back over to my terminal. I'm going to close it down, and then I'm going to rerun that same function that we just did. So streamlit run app.py, close my last one. You can see that it's going to initialize our app model. So I'm going to go once there, actually that's only once upon a time. Let's go a short film about, and then go generate my plot. So you can see it's taking a little bit longer to run here. We've got no, we can't see anything on the front end just yet, but if we head back over to our terminal, we can see that the result has been logged to the console. So that's great. So the last step is going to be taking it from the console and presenting it to the user on the front end, which again is super simple, which is great news. So to do that, we just need to go, we need to declare a chat message. And we are going to go st.chat message, and then we just need to pass the name of the author of the chat message that we want to declare. In this case, because we are just speaking to a bot, we're going to specify it as assistant, and then all we need to do is just go chat message dot markdown, and then we can just pass in generated plot. And now if I hit save, go back over to my terminal, I'm going to stop this from running, and then I'm going to restart it once again. Close my last one. We can see that the app model is once again initializing. I'm going to go a short film about, and then go generate my plot. A short film about an old woman whose father died and was raised as a young boy by his wealthy father. So this is all looking pretty good, but keen eyes might have noticed that this looks like it's actually inside of an array. And so to actually work around that is super straightforward. All we need to do is just grab the first element of our generated plot. So we go model.generate plot prompt, and then we're just going to grab the first element inside that array, which is going to be a string. So I'm going to hit save, and for one final time, I'm going to stop it and restart it. Going to get rid of our last one, and we can see the app model is initializing, and here we go. So we'll go a short film about a man, generate my plot. A short film about a man and woman is produced by Harold Filefender. So this is working exactly as we had expected it, and this really didn't take a lot of work. Streamlit is just absolutely fantastic at doing this. And so yeah, that's the end of this sort of very quick crash course in getting your first AI app off the ground. There's obviously a lot more that we've skipped over, and there's a lot more that you can do, not only with the model, but with Streamlit. I would suggest having a look at the resources that are in the description below and just checking it out, seeing what other things that you can do, maybe even spot some inspiration. And yeah, I'm really excited to see what you make. Okay, that was a lot. So thanks for watching. I hope you got something out of it. I know that this tutorial in particular is quite heavy. Do let me know how you got on. I did say at the beginning, if you enjoyed it, please subscribe, because it's a good flag to me to continue making this kind of content. If you didn't like it, or if you maybe have some feedback, or if you had a question or something along those lines, please do drop it in the comments. Thanks again for watching, and I'll see you in the next one. Cheers.